In this problem, they give us that the graphs of f of x equals absolute value of x plus 2 minus 3 and g of x equals negative absolute value of x plus 1 intersect at points P and Q. AB is the midpoint of PQ, so we want to find the sum of A plus B. Well, if these two intersect, that means that these two are equal. So we have absolute value of x plus 2 minus 3 equals negative absolute value of x plus 1. Now, when we solve an equation involving absolute value, what we have to do is we have to get one expression with absolute value by itself. So what I'm going to do is I'm going to add the 3 over here. So we have absolute value of x plus 2 equals 3 minus the absolute value of x plus 1. All right. Now that we've done this, we split this into two equations. Because this quantity, because it's inside the absolute value, could be positive or could be negative. So that means this quantity could be x plus 2, and that would equal 3 minus the absolute value of x plus 1, or it could be the opposite of this. It could be negative x minus 2 equals 3 minus the absolute value of x plus 1. So we have these two equations to solve, but we still have another absolute value to contend with. So what I'm going to do is I'm going to subtract the 3 in both cases. So I'm going to have x minus 1 equals negative absolute value of x plus 1. And then I'm going to have negative x minus 5 equals negative absolute value of x plus 1. Now I need to get rid of the negative, so I'm going to divide everything by negative 1. So I have negative x plus 1 equals absolute value of x plus 1. And then I have x plus 5 equals absolute value of x plus 1. So now we're going to split this into two equations. So that's going to split into negative x plus 1 equals x plus 1, but it's also going to be negative x plus 1 equals negative x minus 1. This one we also break into two equations. So this is going to be x plus 5 equals x plus 1, and then x plus 5 equals negative x minus 1. So we have four equations to solve, but only two of them are going to work. And that's because with this equation right here, if I add x to both sides, I get 1 equal to negative 1. So that doesn't give me anything. Likewise here, if I subtract x from both sides, I get 5 equal to 1. That doesn't work. So over here, if I add x to both sides, I get 1 equals 2x plus 1. Subtract 1, so 0 equals 2x, so x equals 0. Then I also, over here, I can solve this one. If I add x, so I have 2x plus 5 equals negative 1. Subtract the 5. I have 2x equals negative 6. And then divide by 2. I get x equal to 3. So these are the x values of the 2 points where these two graphs intersect. So we need to figure out the y value of these 2 points. Now what's nice is these are the points of intersection, which means I could plug in 0 and 3 into either one and I should get the same answer. So if I plug 0 into here, 0 plus 2 is 2, minus 3 is negative 1. Alright, and then I'll plug 3 in to that same equation. 3 plus 2 is 5, and then 5 minus 3 is 2. So we have a y value of... Whoops, sorry, that's a negative 3. My apologies. So if I plug in negative 3 plus 2 is negative 1, but that becomes a 1. Minus 3 becomes negative 2. So now we have to find the midpoint between these two. So I take the x values, 3 plus 0, divide them by 2, and do the same for the y's. Negative 1 minus 2 over 2. So I have 3 halves, comma, negative 3 halves. And so actually that's a negative right there. So that's a negative, that's a negative. So that is my midpoint. So we have to add these two together. So we take negative 3 halves plus negative 3 halves, and we get negative 6 halves, which is negative 3. There's our answer, and we're done.